Okay, we can look into this example. So here you can see we are given with a set of data values 3, 6, 9, 12, 19, 23, 33, 27, 21, 22, 30 and 44, and we need to insert these values into our B plus tree. And here is given an order as 4, and you know that we are following the same rule of B tree to identify the maximum number of keys, maximum number of pointers, and also the splitting concept. We will see how to divide the root. So all this is the same as that of B tree. We divide the root if the root is filled with the data values, and we will create a new higher level. But if the non-root node or the internal nodes are becoming full, we split the node into two nodes in the same level. In that case, no new levels are created. Okay, so here the maximum pointer is equal to 4 and maximum key is equal to 3. Okay, next we can insert the values. First value is 3, so we created a node with maximum 3 values can be stored. So first we storing 3, next we can insert next element is 6, next we can insert the element 9. So up to now there is no problem in our constraints. We can insert maximum 3, then upon inserting 12 we can see that our rules are violated, so we need to divide. This is a root node, so we need to divide this node. But here you can see that there are 4 nodes in the, so 4 data values in the row. So we need to identify the middle value. So suppose if number of values is a even number, it is difficult to identify the middle values, but it is a odd number, we can easily find the middle value. So in this case 6 and 9 can be considered as a middle value. So you can either do 1 0 1 2 3, you can give some index numbers, and then you can find the middle value as 3 by 2. So the 3 by 2 gives 1.5. So 1.5 can be rounded up or rounded down. In this case here do 2, and if rounded down you will get 1. So it is up to you to select which one, rounded up or rounded down. If you selected biasing to up, then you have to follow the same rule in the entire tree construction. Don't mix the round up and round down. If you selected round down or down biasing as your process, then you have to follow the round down biasing in the entire construction of the tree. So here I am taking the round up. That means I am following, I am taking the index value 2 as the middle one. So you can either select one. The tree will be different if you select 2 or 1. Okay, so I am selecting 2. If you select 1 as the middle value or 6 as the middle value, you will get another tree. So but you have to follow the same rule for the entire tree construction. So I am selecting 6 as the 9 as the middle value. So since it's a root, I am going to build a new level which contain only 9 and it empty position, and then left it becomes 3 followed by 6, and right there is you have to see a change from the B tree. So one value is 12, but you know that in the from the rules of B plus tree, we said that all the leaf node must contain all the leaf nodes must contain all the data values. So 9 should present in the leaf node. So we have to copy the value 9 into the leaf node. But here you can see 9 can be moved to a left child or as well as to right child, but always we have to move to the right child, because as per the rule we are storing only the lesser values in the left subtree of a particular node. So here the left subtree contains 3 and 6, both are lesser than 9. So lesser than equal to is not there. So all the values in the left subtree should be lesser than 9. So the opposite is can be taken. All the values in the right subtree can be greater than or equal to the node, so we can place 9 here. So you have to remember, as in the B plus tree you have a new rule, you have to insert all the data value in the leaf node. As per the rule, we have to, when we are dividing the root node, we have to put that particular moved value into the right subtree. Next we need to place 19. So 19 should come, we also, as per the binary search tree, first we have to go to the root node and 19 will come to the right of the 9. So we will move to the right subtree, and in the right subtree we will place it in the ascending order. So 19 we will get here, and next value is 23. So 23 will come to the right subtree, but it is actually creating against our rule. So we find the middle value. Again I am taking the biasing to up, that means I am rounding up. So we have to move the value in the index position 2. So in the entire tree I am moving the value in the index position 2. Okay, so the value is 19. We need to move the value 19 to the root or the parent node. Okay, here the parent node is actually the root. And 3, 6, and we know that the left of 19 you have 9 and 12, and right of 9 is 23, but we know that all the data value should comes in leaf node, so 90 should be placed in the right subtree. Okay, next we need to insert the value 33. So 33 can be inserted into the right of 23. So 33 inserted there. Then it comes at 27. So 27 will comes. First we need to search in the root node. You can find 9 and 19, and the 27 is greater than 19. So it will absolutely moves to the which not the right of 19. So 19 we move to the right subtree. Here you can see 19, 23, 33 and 27. 23 must comes between 23 and 33. Don't place it in the right of 33. So from 90 we cancel, and it must be placed between 27 and 33. You know that there is a rule with all the key values should be in ascending order. So we can redraw the same tree. 336, sorry, it is not 36, it is 6 actually, sorry, it is 6 actually. 3, 6, then 9, 12, then 19, 23, 27 and 33. This is not actually correct, because we know that the maximum number of keys is 3. So here you can in order for finding the middle value, I am actually temporarily placing 27 into that node. So we can find that the index 2 contain 27, 0, 1, 2. So middle value I am taking as 27. So if you are looking into the left biasing, you have to take 23. Okay, so 27 should come to the parent node. So 9, and here the parent node is root node. So 3, 6, 9, 12, and you know that 27 should come here, and land in between 27, 19 and 23 in the left of 27, and right you have to 33, and you know the other rule, all the data value should be there. So 27 also moves to the leaf value. So 27 will be in the root node as well as in the leaf node. Okay, so all the data value here you can see all the inserted data value is in the leaf node. Okay, and few values are also in the parent or internal nodes. Okay, next we can insert the value 21. So 21 will comes between 19 and 23. So we need to rewrite. So you have to think how we are identifying that position. We have to start from the root value, and you have to find this 9, 19, then that is 27. So you understood that 19 and 27 is there. So 21 must comes between the subtree of 9 and 27. Okay, we are following the binary search tree concept. So we will follow the binary search tree, sorry, subtree of 9 between 19 and 27, and you will reach 19, 23, and it will place in the 21. 1, the middle of 19 and 23. So 19, and then comes the 21, and then comes the 23, and the remaining node. So there is no restriction, so you have to draw the tree completely with the square brackets, etc. And next we need to insert the value 22. So 22 will comes to 9, then 19, and next is 27. So between 19 and 27, so it should be placed between 19 and 27. So where it comes, the 19, 21, 23. So that node will be formatted like this: 19, 21, 22 and 23. And from here you can identify that 22 is the value that should be moved to the root node. So we can write, so draw the same figure 22, 27. So you know that when moving to a node to the parent level, you have to put that in the correct position. It should be in the ascending order. So 9, 19, 22 and 27. Then the rest of the values can be returned 19, and this is also actually a mistake. You can see that the root node is not following our constraint. We need to split that root node, so we can do in the next step. Okay, so if we place temporarily 22 in the root node, this will be the tree, but it is actually not correct. So we need to remove 22 from here. So we know that when we are dividing a root node, we need to create a new level, and the middle value here 0, 1, 2, this is 22 should go to the new level, and rest of the thing will come in the left subtree and the right subtree. Okay, and here you can see we can write from the previous figure. So 22 should be in the new level, and the left subtree of 22 contain the values 9, 19, then 22, 27. So we have to look into the previous figure. So here 19, 21. So from the previous figure we can see that there are 5 leaf nodes. So already I placed 3 leaf nodes from that figure. So I have 2 leaf nodes left in the previous figure. So 1, 2 and 3, the third leaf node also placed. So 2 leaf nodes as well, but we can see that there are 3 pointers here. What will you do? But only 2 nodes to be placed. So what will we do? So I told you that we have a rule that all the values should be in the leaf level. Here you can see that if you put the remaining 2 nodes into this new level, you can see that this node become the internal node. So 22, 27 is actually inside the tree, or it is a not leaf node or internal node. So actually 22 must not be, or we have no rule like that. 22 must be in the leaf node. It should not repeat in internal nodes. So we need to remove this 22 from this particular level, because we only need to have 22 as the leaf node. So we need to remove this 22. So if as per the rule, we only need all the data value in the leaf node, so we remove that node from the internal node. So that pointer also can be removed. So now we have only 2 pointers. We can place 22 and 23 here, and 27 and 23 here. Okay, so the thing is that here we can find that all the data value is present in the leaf node. We don't want any repeated data or key element in the internal nodes. Okay. So next we can insert the rest of the value. We have two more items left in the from the list. It is 30 and 44. So when inserting 30, it will arrive in this node. It is must be between 27 and 33. So we can redraw the figure 22, 9, 19, 27, then 3 and 6, then 9, 12. We have to complete that round rectangles. Okay, don't write like this. Then 22 and 23, and then comes 27, 30 and 33. Okay, so next item is 44. So 44, okay, obviously it comes at the right of 33, so it is again violating the rule. So we need to for reformat the leaf node. So the middle element is should be the element 2, so it is 33. The position 2 contain the element 33. It should be moved to the parent node, and here you are getting the final tree because the values, all values are inserted. So 27, 33, then here comes the 3, 6, and rest of the values. (22, 23) and 30. The left of 30 is 27 and 30, so it must be the left of 33, 27 and 30, and then right to 33 and 44. So all values should be in the leaf node. So 33 should be in the leaf, and 33 and 34. So we completed the B plus tree. And one more thing is that all the leaf nodes are connected. That is one of the rules. So that's actually creating the advantage of B tree when comparing to B plus tree, that all the leaf nodes can be traversed from left to right. Okay, so this is a way of constructing the B plus tree